Okay, we have an indicator. I think that means we can go ahead and get started. So last time I screwed up and didn't show you the results of the question of the day. So today I'm going to show you two of them. So this was the one that had gone out on Friday that I should have shown you on Monday. Interesting question. I was surprised at these percentages that I thought there might be more people who miss real people. We're going to do an assignment later in the quarter, a personality program. And actually one of the things that you find is that there are a lot of introverts who take CSE 142. So maybe that's an indication of introverts finding that it's not all that different to live with social distancing. And so this was the result then for the question that I put out on Monday that was for today. Interesting answers here as well, kind of, a real split there. No particular agreement in the class. All right, it's Wednesday, so as I had mentioned, on Wednesdays I'm generally going to be releasing homework assignments. So I have put up most of the information for assignment 3. I'm going to finish up, after I finish giving the lecture, so this will all be ready for you. It involves graphics. We're going to be doing the material from section 3G of the book. The specification kind of shows you that you're going to be writing a program that creates this graphical output. It is an optical illusion. I've had students come up to me after lecture and say, how do we make the lines slanty? The lines aren't slanty. The lines are nice and smooth. It's all, if they look slanty to you, then that's because the optical illusion is working, and it doesn't look like it's actually horizontal lines that are involved there. So anyway, that's what we're going to be doing for your homework. There's another little 2-point creative aspect if you're interested for this homework. Let me mention that I've said it a couple of times, that this quarter we're kind of fortunate that we get to have 2 full lectures on graphics. So last time I was looking at this car example, and we spent a fair amount of time writing this initial code. Basically, it's all the drawing commands that you need to give in order to create the car. So we kind of got that done, and we used the compare to web file option to be able to make sure that we had it right. The problem, of course, is that all of the code here is in main, and it only draws one car. So what we were working on at the end there is I was trying to kind of modify it to a program that would take an XY coordinate and rearrange the lines of code so that it could draw at different locations on the screen, so that we could draw 2 different cars on the screen. And I screwed up some of the expressions at the very end, so we didn't get to quite finish this, but that's fine. I mean, the important thing to understand is that the point of this second version of the program was that we made a method, put all that code into a method that's good to do for structural reasons. You want to keep main concise when you can. And the flexibility of providing different XY coordinates for where to draw the car so that we could do 2. And I mentioned to you, that there's kind of this as an optional exercise if you're interested to look at car 3. This is much harder because this one involved not just a different XY location, but a different size. So scaling the car is kind of tricky. It takes a while to come up with the right expressions for scaling the car. So my guess is most of you probably didn't try working on that, or if you did, you found it was a pretty hard challenge. But that one is kind of the nicest version of it when you can do both a location and a size. But we're going to do our own example in the lecture today, so you don't have to understand this car example as fully. We're going to do an example where we're going to create this output here. So there are 2 of these bits of output that are the same size but in different locations. So that's kind of like the difference between car 1 and car 2. We're going to do the car 1 version first, where we create just one of these things. Then we're going to create 2 in different locations, and then we're going to think about doing the size as well, being able to have that one is a smaller version of that same little bit of output. So this is what we're going to do in the lecture today, and this will serve as a guide for you in working on homework 3. So I've been doing that most of the Wednesdays. We've been going over a sample program that's the one to study in order to prepare for doing the next homework. Let me show you, I want to show you one other thing before we do that, though. So here was that car program, car 3, and if I go ahead and compile and run it, you can kind of see that it creates a couple of specific cars. So that was kind of a car over here at 1030 of size 100. Here's a car of size 50. And then Marty Stepp included this in the slides just to point out to you that you can use a for loop to do this. This is a for loop. This is a variation that starts at the 0 and goes strictly less than 5. It's drawing 5 cars. Remember, that's a variant. You know, most of the examples I've shown you start at 1 and go less than or equal to something, but you can also start at 0 and go strictly less than. For some of these graphics programs, the coordinate math works out a little nicer when you start at 0 instead of starting at 1. We don't care. You can do it either way that you want to. But what this is doing then is that it's doing a for loop to create, to draw 5 different cars. And the x coordinate is changing. We're adding in I times 50. So when I goes from 0 to 1, it's going to add in 50 more pixels. That's why this second car is drawn 50 pixels to the right. Then this one is 50 more pixels to the right, and then this one, and so forth. So that's kind of to show you that you can do things in that way. Well, what I wanted to do is, first I wanted to change it so that it's going to make 300 cars, and I want them to be 1 pixel apart. So I'm going to get rid of the times 50. It's just going to be adding I. So I'm drawing a lot of cars, 300 cars, and I'm drawing them 1 pixel apart. And when we run it, we kind of get a stretched limo, I guess, is the way that you could think of what we got there. It drew them all right next to each other. So, I mean, maybe you're interested in that, maybe you're not. But what I wanted to do was to be able to point out to you a couple of extra commands. And these are things that you might want to use for that first part of the homework, the creative part, where you get to do your own thing. You'll see why in a minute, because it gives you some interesting possibilities. So, in general, this drawing panel, we don't do a whole lot with the drawing panel. Here we used it to set the background. Here we used it to ask for its graphics object. But most of the rest was done using the graphics object, not the drawing panel. But and let me mention a couple of extra commands. The panel has a method called clear. And what clear does is clear erases what you've drawn. It leaves the background color, but it erases what you've drawn. So it's going to draw all 300 of these cars, but it's going to erase just before it draws a new car. So let's go ahead. Oops, I don't know if I hit the run command. So we can watch it. I don't know quite what you saw, but it drew 300 different cars, and kind of doing the erase as it went along. One of the issues about this is that the human eye can't keep up with how fast that's going. So there's another command you can give. I'm going to say panel.sleep. That's a command that tells Java to wait a little bit before it does any more commands. So you could kind of imagine that it stays positioned there at that call on panel.sleep, and you give it a number of milliseconds. So I've told it to pause for 10 milliseconds is what I want it to do. So let's go ahead and compile and run this version of it. And now you can see it looks like the car is driving, because I've kind of told it to pause. So there's enough time for your eye to perceive it. If you wanted it to run faster, you could pause every 50 milliseconds, and that's going to redraw the frames. It's going to go more slowly. Because it's waiting. So this is like you're stuck in traffic or something. This is Seattle when we don't have coronavirus, kind of the speed at which you get to drive. So anyway, those are commands I wanted to point out to you, the clear command and the sleep command. And I'll put this on the calendar for today as car 4. This is more just for your own fun if you're interested, because people do tend to have fun with that part A, of the homework assignment, where you get to do your own creative little thing. Okay. So let me switch to our main example. So as I said, this is what we're going to want to do, is we're drawing 3 different figures here. And let me come over here. I have a file set up for us to do this. And I put some comments in here just to remind me of various numbers that are involved here. You'll see the assignment write-up has tons of numbers that tell you the positions of things, the sizes of things. So we're going to be very clear about specifying exactly what it is we want you to draw, where, how big, and so forth. So the first little comment here reminds me that I want a drawing panel that's 500 by 400. So I had mentioned before, but let me remind you that if you go to, well, it's here on the calendar. If you're interested, there's a link to drawingpanel.java here. I also included it on the homework that there's a link here to drawingpanel.java. And it's reminding you, you need this file on your computer to be able to do the things I'm doing. This is a custom class that my co-author and I wrote for the book. It's not part of standard Java. So you have to save this file in the same directory where you're going to be creating programs like this Wednesday program that I'm creating right here. So I have Drawing Panel in that folder where I've written this one, and that's why Java's finding it, and that's why it's working out. So I'm going to say that I want a variable of type Drawing Panel that I'm going to call panel. I could call it anything. I could call it X. I could call it, P, oops, not bracket P. I can kind of call it anything I want. Panel's not a bad name for it. And so this is something where I have to construct the drawing panel. And when you can, so that we make a call on new, I'm saying to Java, hey, go out and make me a brand new drawing panel. And when you construct a drawing panel, you have to tell it the dimensions. And it's the horizontal first, and then the vertical, kind of the X, and then the Y. So we say I want 500 pixels wide and 400 pixels tall. So that's how big I want my drawing panel to be. And if I compile and run this version of the program, I'll see that it brings up a drawing panel for me here, 500 by 400. So that's created the drawing panel where I'm going to draw these various things. Let me also remind you that there's this compare to web file option here. So there's lots of stuff here. I've included your homework now, that these are things you can compare against. There's some section problems you might want to work on that have the ability to compare. There were some problems in the lab. These were the car examples from Monday's lecture. But I want to compare against this one. So I could say, what was I supposed to do? What did I actually do? What was I supposed to do? What did I actually do? How much is wrong? Everything is wrong. I don't even have the background color right. Well, let's at least fix that. Let's say, oops, not up here. We wanted it up here. Let's say, tell the panel. You use this dot notation in order to be able to send a message to an object. So I want to tell the drawing panel, hey, drawing panel, set your background color to be color.cyan. So that is a command we give to the drawing panel. I'm sure this is taking a little getting used to. The section will be helpful tomorrow when the TAs do even more of this practice. Remember that we're now dealing with objects. We're manipulating objects. So we've got to think about what are the different objects involved. What do we say to them? How do we keep track of them? So there's one object here known as the drawing panel object. I've used a variable called panel to keep track of the way of getting in touch with it so that I can say panel dot, panel dot, panel dot. Whenever I want to give a command to the panel, I say panel dot. And the panel, the classic thought that people have is that, this is a painting model. This is like a canvas. Before you can begin painting anything, you have to have a canvas to paint on. And that's the drawing panel. It's a canvas that you can paint on. But the painting then, the actual painting, is done by a graphics object. The visual that I kind of have is I imagine, some paintbrush that we're going to use, but it's not a free-flowing paintbrush that can be used on any given canvas. This is a paintbrush that's tied to this specific panel. So each one of these panels kind of has attached to it a paintbrush, a graphics object that's used for drawing on that canvas, on that drawing panel. And so the drawing panel itself constructs that graphics object. So I don't have to say new to make a graphics object. What I'm going to do instead is I'm going to have a variable G. Nice to use a short name because we use the graphics object so much. And I'm going to say, hey panel, how do I talk to your graphics object? So I'm asking the panel, tell me how to get in touch with that attached a paintbrush that's used to paint on your surface, that's used to paint on your canvas. And then I'm going to give all my drawing commands to G. So the panel is the canvas, G is the attached paintbrush that I use for doing all of my different drawing commands. If I try compiling, I get an error message that probably a lot of you might have anticipated, that it can't find color or it doesn't know what that is. That was, again, this issue that what you're going to have to do, starting with this program, is that we're going to have to do an import. In this case, java.awt, the abstract windowing toolkit, that's where all the graphics commands are. This kind of graphics library is in AWT. So I'm importing all of those different elements of Java AWT. And I can compile and run. And now I'm getting the panel, and my panel is cyan color. So I can go ahead and say compare to web file, and let's see how this compares against the lecture example. And I can say, what was I supposed to do? What did I actually do? What was I supposed to do? What did I actually do? Or I can highlight kind of what's different. Well, and it's the three little subfigures. Not surprising. We haven't done anything for the three subfigures. So there's a lot of detail associated with this programming assignment. I've mentioned to you Kernahan's idea that programming kind of, learning to program involves learning to manage those details, learning to handle the details. And one of the aspects of that is to do things slowly in stages, to build things up a little bit at a time. So I've called that also a development strategy, and that's going to be an issue you have to face for your programming assignment as well. Is that there's, it's kind of overwhelming at first to think of all of the details involved in that write-up. So you want to focus on something small, kind of start with something small and then move up from there. So first of all, I'm going to ignore these two figures. I'm only going to think about the one in the upper left corner. I've picked a specific one. I've suggested that you do the same thing in your homework assignment, that you pick a specific, there are rows, there are grids, they're in different places on the screen, and I've kind of said do one row first, and get that to work. So we're going to do this subfigure first, the one in the upper left corner. Okay, so let's come back here. I'm being reminded that it's got an upper left corner of 50-50 and a lower right corner of 150. If I come back over here and take a look at, that's my drawing commands. So what it's telling me is, what were those coordinates again? It's telling me 50-50 and 150-150. It's telling me that the upper left corner here is 50-50 and the lower right corner is 150-150. So that's kind of the way it's describing, the location to me is the upper left and the lower right. We need to give several different drawing commands here. Normally what I'd say is, hey class, where do you want to start? I can tell you that 90% of the time when I ask people where they want to start, they usually talk about doing the square, the red square that we have here. So I have to figure out, how do I draw a square? I showed you this last time. Let me remind you, in the slides for today, there's this table of graphics methods that should always be available to you when you're working on a program like this. You don't have to memorize these things. You can just kind of be looking them up and remind yourself of the parameters. Tomorrow in section, when the TAs go over this, they'll probably point out to you that on the Sections tab on the class webpage, starting tomorrow, there will be a cheat sheet for this section, and it'll have all of this table in it and more. It's a very nice one-page summary of the graphics command. So the section cheat sheet that becomes available on the class webpage tomorrow for you to start working with in section. So that's but it's also in the slides, also in the book. So what do we want to do here? We're trying to draw something square. We don't quite have a square command, but we have a rectangle command. We could use the draw rect command, but remember, draw rect draws an outline of something. And so there's the variation known as fill rect that fills the whole rectangle. So the two variations of both the oval command and the rectangle command. So there's the drawing version that does an outline and the filling version that fills in the color. We want the filling version here. And so we know that what we want to do is to have a call on g.fillRect. And what are the parameters that we supply to it? The first parameters are the xy of the upper left corner. Well, we have that. The upper left is 50-50, so we know that's what we'd supply. And you might think you do 150, 150. Java could have done that. When you draw a line, that's what you do, is you give it the two endpoints of the line. So you could imagine that that's how they would have done it for a rectangle, but it's not. They have you give the width and the height, so it's slightly different. It's not 2 points, it's 1 point and then a height and a width. So we have to, think about, well, if you're going from an x-coordinate of 50 to an x-coordinate of 150, what's the width then? What's the difference between those two? Class can all say 100. And similarly, well, we're going from a y-coordinate of 50 to a y-coordinate of 150, so that's also 100. So a width of 100 pixels and a height of 100 pixels. So we want to draw a rectangle, fill in a rectangle that has that upper left corner and that size. So, and I could even position here and see that that's kind of, it's hard to get my cursor right there. 50-50, and then kind of there's the 150. So it drew the right thing. But it's black. It's not red. Well, I kind of did that on purpose. The paintbrush is initially drawing in black. So that's kind of the initial color, is it's drawing in black. So if we wanted a red square, we'd have to say g.setColor. Again, don't have to memorize anything. All these commands are here. There's g.setColor. And I'm going to give it the color constant, color.red. Some of you may be interested when you're doing your creative aspect that you'll find that you can make your own colors. The textbook talks about it, that at Supplement 3G. The slides, I think, give an example of it. So there are some specific color constants, and we typically use standard colors like this, for the homework or for these examples. But if you want to explore on your own, you can make your own colors if you're interested, when you're working on your own little programming assignment, or have a for loop that varies the color, as you go through the loop. Anyway, so a red square, let's go ahead and see if we can do that. And we've got a red square, which is good. So I could do a compare to web file and make sure that, I'm kind of in the right spot. I can highlight the differences. And so you can kind of see that there's parts of the lines that aren't right. The circle inside isn't right. There's something that's hard to see here, but let me mention this. And by the way, there's kind of a cute little command here where you can say zoom in and you can say zoom in so you can see it bigger. Take a look. This is all solid red. Well, let me tell you something that would have been in the fine print, in something like a homework specification. So this is a red square, but it has a black border. So I do want the inside of the square to be red, but I want black on the outside, a black border on the outside. So, and if you take a look over here, do we have a black border? No, it's all red. So we want to fix that. So let's go back to our program. Although before I do that, let me just kind of point out, this is a place to use the draw rect. I want to draw an outline. So now I want to kind of draw the black border. And I use the same values, the same upper left corner, the same size. Now the pen, the paintbrush, or the pen we sometimes refer to it as, starts out black. So how about if I do g.drawRect 50, 50, 100, 100? How about if I take advantage of the fact that it's black to begin with and go ahead and let it draw the outline first and then draw in red? And if we compile it and run it, and here it's very helpful to do the zooming command. You kind of see what's here. We could zoom it again and take a look. Is there a black border? Sort of. There's kind of a black line here and there's a black line here, but I don't see a black border here or a black border here. This is a little bit odd, so let me explain what's going on. Remember that it's a painting model and you can end up painting over. So you have to do things in just the right order. And what it did here is, if we had more time, I'd kind of show you. We could do it slowly in the debugger, and we could watch the black outline being drawn. It is drawn, but then when it does the filling command, the convention that it uses is that it decides to draw red. That's part of its filling operation, that it draws red here and here. So it overwrote, it painted over the black outline with some red. You might think that's stupid. It should only be going inside. It shouldn't be drawing, but that's what it does. So it kind of, it ended up erasing part of our outline. So what I'm going to need to do is to take this line of code and bring it down to here. So I want to do it after I draw the red, fill in the red square. And then I'm going to have to, we can do the classic thing here. If I do the draw rect, I compile and run, and what we're going to find, I'm not even going to bother with it. I think you can see what's going to happen. It's going to draw a red outline around a red square, which isn't going to work. One of the most common things that you do is you forget to reset your color, right? So we'll reset to black so that we can draw a black outline around a red square. We can go ahead and run, and now if we do a zoom in, and we could do, say, another zoom in to take a look, and now we've got black all the way around. So that's good. That's giving us our black border. All right, what next? You can see that each of these figures has a green circle in it. It kind of comes out as a strange color here, but that is green. That's what it calls green. And so we're going to want to do a similar kind of command, but to make a circle instead of making a square. And so the commands in the drawing, the graphics commands, are oval commands, because you want to be able to have it stretchy this way or stretchy that way. We happen to be drawing circles, but oval is the generalized version of it. And so we want to do a fill oval in order to be able to draw a green circle. And remember the convention for ovals and circles, that you give the bounding rectangle of the circle that you're interested in, and it draws the largest oval it can within that bounding rectangle. And so this is meant to have the same, boundaries as the rectangle we just draw, the square we just drew. So it's going to have the same coordinates. It's going to have the same upper left corner, the same width and height, because the rectangle we just drew here, the square we just drew here, is the bounding rectangle we want to use for the circle that we want to draw. So I can come back, we can go ahead and end this, and I'll come back over to JGrasp. So we have to remember to set our color to be color.green, because it's not going to work otherwise. And we can do g.filloval, where we give it the same, basically these same coordinates. 50, 50 for the upper left, and 100, 100 for the width and the height. So we'll draw a green oval, and we can go ahead and let that run, and we'll see our green oval, our green circle, which is right there. Well, it doesn't seem to be right there. Probably a lot of you caught on. Normally, if I do this in a lecture hall, I hear people moaning and stuff because they know this isn't going to work. They've caught on by now. There's this issue of the order in which you do things, right? So there's the issue of painting over things. So again, I could use the debugger in JGrasp and watch this slowly, and I'd see that it really did do a filled green circle. That's just the right circle. But then it said, well, then paint a red square over the green circle. So the green circle was painted over, and we just end up with the red square with its outline. So we got to do things the right way. We don't want to draw the circle first and then draw the red over it. The way that this figure is done is that the green circle is drawn over the red square. So we got to get that right in terms of the order in which we do these things. So let's go here. So setting the color to green and filling in that green circle is something that we want to do after we draw the red square. So let's try compiling and running that version of it. And now we're getting a green circle here over our red square. We could compare to web file and see how we're doing. We can ask it to highlight the differences. And I think I can actually see that here when I'm glancing up at the screen. It's a little hard to make out on the smaller screen here. But you can see it's telling me that I don't have the diagonal lines. We knew that. We haven't done that part yet. But you might notice there's kind of a purple outline here. Well, that's because for the circle as well, I want a black border around the circle. I want a black border around the circle, and I haven't done that. So let's go back in. Oops, we're done with that execution, and we can come back into JGrasp. So you know, basically in terms of the order in which we're going to paint these things, we paint the red square, we paint the green circle over it, and then we can do all of our black drawing after that. So, you know, kind of the ordering would work to do, let's have the red square filled in, then let's do the green circle that covers up part of the red square. Then we'll make a border around the square, we'll make a border around the circle, and then finally we're going to draw our lines. So here we drew the rectangle. Remember, draw rect did the border instead of doing the filling. And similarly, draw oval is going to do the outline rather than the filling command. Again, the same coordinates, upper left 50, 50, 100, 100 for the width and the height. So let's see what happens when we compile and run that. And we could do a little zoom to take a look. And you can kind of see there is this black border that it's drawing around the circle. So now what we need to do is to draw the diagonal lines. There's different ways of thinking about drawing the diagonal lines. I'm going to tell you kind of my way that I do it. This is a medium hint for the homework assignment because you guys have to draw diagonal lines as well. So line drawing, remember, we can go back and remind ourselves about the line drawing command. It does take 2 points. So it doesn't do this width height thing. It's the x1, y1, and the x2, y2. So we really do want to give it the position of that upper left point and the position of that lower right point. That gets me this diagonal that goes this way. And we had those numbers available to us. So, oops, I want to be up here. So we can say g.drawLine, and it's between these 2 points, the upper left and the lower right. So 50, 50 from that point to 150, 150 is the way to get the first diagonal. You know, usually it's not so hard to figure out the first diagonal. It's the second diagonal that's a little bit tricky. Well, that's not hugely tricky, but you know, there's math involved here. So I'll tell you the way that I like to think about it is that I like to think about the fact that this other diagonal has, you know, the 2 points have the same x and y coordinates as the other point. I mean, you know, we're drawing at the same x locations and the same y locations, but they're kind of switched. So here's what I do. I say g.drawLine, and I use 50, which was the x coordinate here, and I'm going to put a question mark, and I use 150 as the x coordinate here. So I keep the x coordinates the same, 50 for the first point and 150 for the second point. And I know then that what I want to do is to switch the y coordinates. So whatever is here for the y coordinate, that goes over to here. So that goes to where that question mark was. And whatever was here in the y coordinate, that goes over to here. So that's kind of just, I keep the x's the same, switch the y's. That's kind of the way that I like to think of drawing those lines. So we can end the old execution. Let's compile and run this version of it. And that's looking pretty good. I think that's our figure is looking pretty good. But let's do a compare to web file and use our lecture output to see how we're doing. And we can highlight differences. So clearly we knew that these two were not done, but there doesn't appear to be any purple up here. So that's good. I think that we've got one of these things right. That's a great milestone to reach. Notice that even in getting this right, I did it in stages. You know, the red square, the green circle, the borders, the lines, you know, building it up slowly, step by step, testing, making sure that what you've done so far works right, ignoring the stuff that you're not ready to work on yet. That's kind of the key to success on dealing with all the little details involved in a program like this. All right, well, I'm going to do something here which is a grievous sin. It's kind of, you know, it's something that you should feel bad about when you find yourself doing it. But it's not a bad way of understanding what's going on here. I made a copy of all of those lines of code, and I'm going to paste it all here, and I'm going to paste it all here. I told you that, you know, it's kind of a general rule of thumb among programmers that if you ever find yourself doing copy-paste of a bunch of code, then you should be thinking about whether you've missed an opportunity to get rid of that redundancy. Is there some better way to go? But it's a way that works, so actually for now, I'm going to go ahead and do it this way. So the second figure we were supposed to draw had an upper left corner of 100, 200. So I'm going to put 100, 200 here. That's the upper left. And what's its width and height? Well, notice that the difference between these x's is 100, and the difference between these x's is 100. So it's the same size as it was before. It's a size of 100 by 100. And, you know, this example, I mean, this is a lecture example, so it's meant to be simpler than what you'll do in your homework. You'll notice that we ended up using the same, you know, numbers in all of these different commands. We were basically specifying a single rectangle that was used for all of these things. The lines were a little bit different, but we'll get to that. But, you know, when we did the fill rect and the draw rect and the fill oval and the draw oval, we were using this set of 4 numbers. So I'm going to just go to those 4 different places and paste in these numbers instead. There was a draw rect command, so I'll put those numbers in. Here was a draw oval command, so I'll put those numbers in. Now for the draw line, that's different. So here, you know, I have my 2 points. I can say I'm going from the point 100, 200, that's the x1, y1, to the point 200, 300. And remember what I said about what I do for the second line is I keep the x's the same. So I kind of figure out that the first x was 100 and the second x was 200. I keep those the same. And then what I do is I take this number here and I put it over here. So that 300 goes over there. And I take this number here and I put it over there. I put a 200 there. So let's go ahead and compile and run this version of the program. And we've got 2 of these things now, and I could do the file compare to web file, the lecture example, and I could have it show me what's different. There's just one of these things that's different. You might wonder, I mean, didn't I make 3 copies of this code? Why am I only seeing 2 things? Well, I only adjusted one of the copies of the code. It's basically drawing that figure, the upper left figure, twice, you know, because I never adjusted the things here. So let's adjust these in a similar way. They have an upper left corner of 250, 150, 250, 150. And then what's the width and the height here? Well, the difference here is 75, and the difference here is 75. So they have a different size to them. So these are 75 by 75. And I can do the same kind of thing I did before. I can do that for all of the oval and rect commands. I can just kind of paste those new numbers in. For the draw line command, I know that, I wanted to go from the point 250, 150 to the point 325, 225. My trick with the second one, again, is to keep the x the same, and 325 question mark. So I don't know what the y's are yet, but I keep the x's the same. Then this y goes over to here, 225, and this y goes over to here, the 150. And let's try compiling and running this version of the program. Now we've got 3 figures, and if I compare to web file, to our lecture example, 0 pixels differ. That's where we want to get to, is that we've got it exactly right. We've drawn the figure just right. So that's good. I mean, basically now we've got the credit for external correctness. We are drawing the correct output, and that's a good place to be. So I do think it's worth understanding this version of the code. It's very redundant, but it is worth understanding. You could just put all of the commands in main. You know, that's a way of doing this, is that main could be this really long thing that just had all of this stuff in it. But then you don't have to think about methods and parameters and all of that stuff. You just put all the commands you need in main. I'm going to call this draw1.java. So it's kind of a first version. It works, but it doesn't have good structure, and it's highly redundant. So what did we do for structuring things all the way back with, chapter 1, is that we said, well, look, if there's 3 figures, how about having 3 methods? So how about if I have draw1, draw2, draw3, and then what I can do is I can come down here, and I can say public, static, void, draw1. So let me kind of give this thing a better structure by at least introducing some methods, that kind of have the first bit of code. I mean, for the first figure, public, static, void, draw2. For the second one, and it needs a closed curly brace as well for its code. And then here we have a public, static, void, draw3, which would be this third bit of code. So this is at least nicer in that main is short. You can kind of see we set things up, and then we call the 3 different drawing methods. So this would be better if we did it. We get a huge number of errors. You don't even want to see how many errors. There's tons of errors here, and they're all basically the same error over and over again. That was not where we were. Let me hit compile again so I can see it. Let me compile so I can get it to show me that first error. It cannot find the symbol G. So the issue here was all the G dot. It can't find G. This is a scoping issue. We talked about this in Friday's lecture. This is where we set up G. But here's where we're using G, down here. So you could say, oh, well then maybe I should move this line of code into draw1, set up G there. Yeah, but then it would need to talk to the panel, which means that like this code would have to move into that method. And we don't want to make 3 drawing panels with 3 methods. So we have to figure out a way, it really is right that main should set up G. That'll be true in your program too. That's what we do in these drawing programs. We set up G once in main. But then we need to get G into these other 3 methods. And that's what we talked about in Friday's lecture, the whole idea of information flow. The one method knows about G, the other method needs to know about G, so we pass it as a parameter. So G is going to be passed as a parameter to each of these different methods. So we're going to do graphics G as a parameter to the draw1 method. We're going to do graphics G as a parameter here, and we're going to do graphics G as a parameter here. So we have to do that. That's the scoping issue. We have to pass in graphics. And that'll be true in your program too. You're going to be passing graphics G, to all of these different methods you're writing that are going to be doing the drawing, because otherwise they won't have access to the graphics object. So that kind of compiled now. So this is a program with a better structure, but still highly redundant, because those 3 different drawing methods are very repetitive. But it's worth kind of, understanding this version as well. It's an in-between version. So I'm going to save this as draw2.java. So you can kind of see this in-between version that's got better structure, but it's still lots of redundancy. Well, I mentioned an idea on Friday that you could imagine taking all of this, draw1 method and kind of superimposing it, like if you made overheads of these things and put the 3 things on an overhead projector. We know that there's a lot of redundancy because we used copy-paste to make these things. So you put draw1, draw2, draw3, and you kind of overlay them on top of each other. And what you find is that the things that differ from one to the other is location. So this, if we're trying to, the idea is to squeeze the 3 methods into one. to squeeze the 3 drawing methods into 1 drawing method. So we want a generic drawing method rather than 3 specific methods, a generic drawing method. Well, what varied as we went from one version to another version? The upper left corner varied, the location. So 50, 50 was the upper left we used here. 100, 200 was what we used here. 100, 200 was what we used for the second one. And 250, 150 is what we used for this one. 250, 150 is what we used for this one. So we're going to want to have parameters here, introduce parameters for the x and the y that are the upper left corner. You should be commenting methods like this. You should kind of have a comment that talks about what it does, comment, and it should talk about the parameters. It should mention what the parameters mean. In this case, what the parameters mean is the coordinates of the upper left corner. So that was kind of changing from one to the other. The other thing that was changing here was the size. So sometimes we were using 100 by 100, then this one was 100 by 100, and this one was 75 by 75. So we used a different size. I did have in mind here that there's only one size parameter, that we're drawing squares and circles. So I don't need 2 size parameters. I only need 1. And so it was 100, size 100 in the first 2 cases, and size 75 here. So we want to be able to introduce a size parameter as well, in size, that tells it the pixel size on a side. It's squares and circles, so we only need the 1 parameter. And if we do this right, we're going to be able to delete draw 2 and draw 3. So we're going to be able to get down to a much shorter program that has a nice short main, and then the draw, the draw method, the generalized draw method. So I've kind of set it up. Let's go ahead and try compiling and running it and see what we get. And we'll see our 3 figures on the drawing panel. Why don't we have 3 different figures? We called it 3 different times. Well, putting parameters in the header isn't magic. It doesn't make it work. Look, it's still got all those numbers for when we were doing 50-50 to 150-150. So we never generalized this. So where did those numbers come from? We used 50-50 because that was the coordinates of the upper left. So that's now xy. We used 100-100 because that was the size. Well, now we have a thing called size. So we can use size by size for the width and the height. So we need to be using our parameters, so that we're actually going to get it to behave differently when we make different calls. Because otherwise, if we're not using, the x, y, and the size, then it's not going to vary what it's doing. It's going to be, oops, that wasn't what I wanted to do. What did I do? We wanted to select these 4 right here and paste. Oops, I think I've done something wrong here. Let me go back and grab my XY size, and then let's try pasting it here. Let's try pasting it here. Now the diagonals are a little different. So the XY is the first point. Remember the diagonals, you give the endpoints. So XY, that is one of the points. But the other endpoint was where. So we're not specifying anymore by using an x2 and a y2. We're giving a size. So it's, from the x coordinate, how far away is the other one? It's size away from the x coordinate. And y plus size to get the y. And then here, again, if I just do the same trick I mentioned before, I keep my x coordinates fixed. So I'd used x and x plus size, so I keep those the same. And here I do y plus size, that comes over here. So y plus size comes over here. And here it was y, so that comes over here. So again, I just did that trick of keeping the x fixed and switched. And I think I have some stray little thing in here that I didn't mean to have. So let me get rid of that. Let's try compiling. I hope I didn't introduce another glitch. Looks like I didn't. We can go ahead and compare to web file to make sure that that's still 0 pixels of difference. So this is Again, the model that you're going to be following for your homework assignment is I want you to come up with a generalized method using parameters that's going to be able to solve many different tasks by feeding in different specific values. So the assignment write-up is very clear about this. It recommends that you first do something that creates a single row of this output and then something that makes a grid. And I've asked you to have separate methods for row drawing versus grid drawing. I'll show you one last thing just briefly. So from the main class page, I haven't shown you this before, but there's a lot of links that I have here. And this Java API documentation is one of the most useful links here. You know, look at all these different classes in Java that just begin with an A. I mean, this is something, when I look at this, I just laugh. You know, is there anybody who understands even 1/10, of what's in here? But the graphics class that we're using is a part of standard Java, and if you want to read about it, there's a lot of internal documentation that mentions a whole lot of methods beyond what we're doing. It does have things that we're doing, like it'll have the draw line and draw oval, which we're doing, but there's other things in there too. So if you're interested in exploring, you can check out the graphics documentation. All right, I think we're at time, so that's it for today.